Perspective, Class 11, Video 2. In this video we're going to continue talking about vanishing points. In particular, in this video we're going to talk about the vanishing points which arise from projecting lines which are not necessarily parallel to a coordinate axis. So in the previous video we only spoke about projecting lines which are parallel to a coordinate axis, or equivalently which are perpendicular to the viewing plane. But now we want to know what happens when you project lines just in general, like a general arbitrary line. So it could be like a diagonal line or something like this. So let's go straight to an example. Here's some line, 402 plus t times 264, and I want to centrally project it onto the x equals 2 plane. So the same technique as before. The way I'm going to do this is I'm going to test some points, see where they get sent, and try and see if I can find a pattern. So when I plug in t equals 0, like that, what do I get? I just get 402, and I'm centrally projecting this onto the x equals 2 plane. So this gives me this right here, which is just equal to 201. If I plug in t equals 1, I get 402 plus 1 times 264, which is 666. Okay, which gets mapped to 2 times 1, 6 over 6, 6 over 6, which is just 222. If I plug in t equals 10, I get 402 plus 10 times 264, which is 4 plus 20 is 24, and 0 plus 60 is 60, and 2 plus 40 is 42. This gets mapped to 2 times 1, 60 over 24, comma, 42 divided by 24, which is equal to 2, 5, 42 divided by 12, whatever that is. And let's do t equals 100. So this is 402 plus 100 times 264. So that's 204, 600, 402, which gets mapped to 1 comma 600 divided by 204, 402 divided by 204, which is 2 comma 600 divided by 102, 402 divided by 102. Whatever they are. I'm not simplifying them as much as possible. I'll just leave them like that. Okay. So what's the pattern here? Well, it looks like the first number is always going to be a 2. This here, it's pretty close to 6, right? Like 600 divided by 102, that's pretty close to 6, and 402 divided by 102, that's pretty close to 4. So it looks like it converges to 264. Okay, that would be my guess. But to prove this algebraically, we take a general point. So if we have a general point on the line, so that would be a general point would be 402 plus t times 264. So that's 4 plus 2t, 0 plus 6t, 2 plus 40. Okay, and what happens to this point? Well, let's think about this. 4 plus 2t, 6t, 2 plus 4t gets mapped to 2 times 1, 6 divided by 4 plus 2t, 2 plus 4t divided by 4 plus 2t. And I can simplify this a little bit. This is 2 comma 6 divided by 2 plus t, 2 plus 4t divided by 2 plus t, like that. Okay. Oh, I'm sorry, I've dropped some t's, like that. Okay. So now the question is, what happens as t gets really big? So as t goes towards infinity, what happens? Well, a bunch of things happen. Like 2 doesn't do anything at all. 2 stays 2. 2 doesn't change at all. 6t divided by 2 plus t. Well, as t gets really, really big, this bit gets like 6 times really, really big. This bit gets 1 times really, really big. And this 2 doesn't change at all. So this thing here, it sort of just looks like 6t divided by t, which is just 6. Okay? As t gets really, really big, this 2 becomes negligible. And finally, 2 plus 4t divided by 2 plus t. Well, as t gets really, really big, this sort of looks like 4t divided by t, which is just 4. So put all this information together, and you end up with 264. And this is the vanishing point. Okay, that's the vanishing point right there. So if we were to try and draw this, what would it look like? I would draw a coordinate axis like this. This is the x equals 2 plane. So this is z, this is y. Okay, and I know the vanishing point is 264. So that's 6, 4. This is the vanishing point. Okay, and I want to plot the complete image of this line. So I just need to find one other point. So this one here will do. When t is equal to 0, it goes to 2, 0, 1. So when t is equal to 0, it goes to 2, 0, 1. So this point here corresponds to t equals 0. And I know it vanishes at this point here, so the line has to be, well, the half line has to be like that. That was supposed to go through that point. Okay, this is the image of the line under central projection. Okay, and when you answer these questions for the homework and for the exam, you know, this is the type of answer you should have. So you should state where the vanishing point is, and then what you need to do is find one other point, any other point. I found the point corresponding to t equals 0, I plot it, and then I join them up with a line. Like I say, this line is supposed to go through that point. So we can see examples of this in real life as well. Let's look at this picture right here. So here's some picture of a building, right? And notice there's a bunch of lines. Like if you follow the contour of the roof, that's a line. And as that line is extended off to infinity, it seems to converge and vanish at this point right here. And notice lines which are parallel have the same vanishing point. Like all these lines here, they're parallel and they all go to the exact same vanishing point. And this is very important, okay? So parallel lines have the same vanishing point. Okay. So in this picture, this is the vanishing point for lines which are parallel to these lines right here. And this one over here is the vanishing point for lines which are parallel to these lines. So in real life, every possible like direction for a line has a vanishing point. Okay. Working out the vanishing points takes us a lot of time, right? All of this work, all this algebra. But there is a theorem which tells you the answer straight away, and it's right here. So I highly recommend that you memorize this theorem. Okay. So this theorem says if you have a line PQR plus TABC, so very general, and under central projection onto the x equals d plane, this line maps to, well, it maps to a full line if a is equal to 0, and if a is not equal to 0, it has a vanishing point, and that vanishing point is d b over a c over a. Okay, so d b over a c over a. That's the vanishing point. And similarly, if you map it onto y equals d, if b is equal to 0, it maps to a full line, so i.e. no vanishing point in this case. But if b is not equal to 0, then it has a vanishing point, and the vanishing point is d a over b c over b. And finally, if you map onto the z equals d plane, if c is equal to 0, no vanishing point, it goes to a full line. But if c is equal to not equal to 0, then there is a vanishing point, and the vanishing point is d a over c b over c. Okay, so it's very useful theorem because it cuts out all of that algebra which we did above. Okay, that's the end of this theorem, and that's the end of this video.